Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to add, subtract, multiply, and divide integers, how to add and subtract fractions, how to find common denominators, how to multiply and divide fractions, how to find the reciprocal of a fraction, how to simplify mathematical expressions using order of operations, how to recognize like terms in mathematical expressions, how to combine like terms in mathematical expressions, and how to solve multi-step equations for a variable. How are we learning it? Through the Foundational Skills Review Notes and the Foundational Skills Review Assignment, as well as the Foundational Skills Test Assignment. When can you use this information? To determine the amount of money in a bank account after a series of withdrawals and deposits, to calculate real-world scenarios such as splitting checks or calculating the sales price of an item, to prioritize tasks in your life and arrange them in a particular order, to group similar items together in order to simplify your lists, and to determine how long it might take you to save up enough money to buy a car. How do you know you learned it? By getting a score of 4 on the Foundational Skills Review Assignment and a 4 on the Foundational Skills Test Assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Foundational Skills Review Notes, and then I'll give you time to complete the Foundational Skills Review Assignment. As we get towards the end of class, we'll go over the Foundational Skills Test, which will be a take-home test that you'll complete at home. At the end of class, we'll go back over the learning goals and success criteria while you fill out your Before You Go. Your homework for tonight is to complete the Foundational Skills Test and any incomplete assignments that you may have. Let's take a look now at the Foundational Skills Review Notes. Our notes begin with our learning goals and success criteria. First of all, what is an integer? An integer is any positive or negative whole number. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, and 0. All of those are integers. So it doesn't include fractions, it doesn't include pi or anything like that. Integers are just the whole numbers and the positive and negative versions of those. So for instance, negative 2 and 2 are both integers. And we can think of negative 2 as being the opposite of 2. So if we're adding two positive integers together, we're going to do this on the number line. So we have 4 plus 3. So what we do is we're going to go ahead and go to 4. Right here, we start there. And we're going to add 3. So we're going to move 3 to the right. So we move 1, 2, 3. And now our point ends up here. So we added these together. Now we know 4 plus 3 is 7. That's pretty simple. But when we get into negative integers, now it changes a little bit. So let's look at 4 plus negative 3. So again, we start at 4. And this time we're going to add. But instead of adding to the right, we're going to add the opposite direction because we're going opposite here. So we're going to go 1, 2, 3 in the opposite direction. And we end up at 1. So 4 plus negative 3 is 1. Now if we add two negative integers, so we have negative 4 plus negative 3. So we're going to start here at negative 4. And we're going to add the opposite, right? So we're going to add, instead of going to the right, we're going to flip and go to the left. So we're going to go to the left. 1, 2, 3. And we end up right here at negative 7. So integer rules. Here's the easy way to do it without a number line. So first thing we need to determine is, do they have the same sign or opposite signs? Well, in this case, we have a positive 10 and a negative 12. So those would be considered opposite signs. Now, if they have the same sign, we're going to add the bigger number plus the smaller number, so 10 plus 12, and keep the sign of the bigger number. Pretty simple. Now, if they have opposite signs, we're going to do the opposite operation. So we'll subtract the bigger number minus the smaller number, and then keep the sign of the bigger number. For instance, in this case, we have 10 plus negative 12. Well, those are opposite signs, so we're going to take the bigger number, which is 12, and subtract the smaller number, which is 10. So 12 minus 10 is 2, and then we keep the sign of the bigger number. The bigger number was negative 12, so we're going to keep the sign, so it would be negative 2. Now subtracting integers. So we have 4 minus 3. So we start at 4, And minus means we're going to go to the left. So we start here at 4. When we move back 3, 1, 2, 3. So we should end up at 1. Now what if we're subtracting opposite integers? So we're going to start here at 4. And we're going to go back -3. So we're going to go back this way, but again, we're going to go back the opposite way. So that means we're going to end up turning around and coming this way. So we're 1, 2, 3. So we should be at 7. So 4 minus -3 is positive 7. Now, what about -4 minus -3? So we start here at -4, and we're going to move back negative. So we're going to move back the opposite. So we start going this way, but then we're going to turn around and come back. 1, 2, 3, and we should end up at -1. Now, subtraction rules. Here's the rules for subtraction. If they have the same sign, so first thing we have to determine is, do they have the same sign? So if they have the same sign, subtract the bigger number minus the smaller number, and then keep the sign of the bigger number. If they have opposite signs, add the bigger number plus the smaller number and keep the sign of the greater number. So let's look at some examples of adding and subtracting these integers. So we have 4 plus -2. Well, first of all, we should notice that they have opposite signs. So we're going to subtract. So 4 minus 2. So 4 minus 2 is 2. And we're going to keep the sign of the bigger number, which in this case is the positive, so it's positive 2. Now let's look at this one. We have -8 minus 6. So again, they are opposites. We have a negative minus a positive. So we have opposites, so we're going to add them. So 8 plus 6 is 14. Keep the sign of the bigger number. The bigger number is 8, so we should end up with -14. Now we have -4 plus -6. These have the same sign. They're both negatives. So we're going to add them together. So we get 4 plus 6 is 10. Keep the sign of the bigger number, which is 6. And it's negative. So it's -10. Now 12 minus 4. Same sign, right? Because they're both positive. So we subtract. So 12 minus 4 is 8. Keep the sign of the bigger number. So 12 is the bigger number, which is positive, so it's positive 8. Now let's look at multiplying integers. So we have 5 times -2. This is an example of multiplying integers. First thing we need to determine is, do they have the same sign or opposite sign? If they have the same sign, we multiply the numbers and make it positive. If it has opposite signs, we multiply the number still, and then we make it negative. Division rules. Same thing as multiplication, we need to determine whether they have the same sign or opposite signs. If they have the same sign, divide the numbers, and then make it positive. If they have opposite signs, divide the numbers, and then make it negative. Let's look at some examples. We have 4 times -2. Well, we can see that this is positive and this is negative, so they have opposite signs. We're going to multiply them together. So 4 times 2 is 8. The signs are opposite, so we're going to make it negative, so this becomes -8. Now we have -12 divided by 6. So we're just going to go ahead and divide. So 12 divided by 6 is 2. And when we do that, now we can notice that they have opposite signs because this one's negative, this one's positive. So we're just going to make it negative, so this becomes -2. Now here we have -4 times -6. So we're just going to go ahead and multiply. So 4 times 6 is 24. They have the same sign, so we're just going to make it positive. So this becomes positive 24. Now 12 divided by 4. We're just going to go ahead and divide. So 12 divided by 4 is 3. They have the same sign, so we're going to make it positive, so we get positive 3. Now, operation notations, there's certain ways we can write addition, subtraction, multiplication, and division. Addition, we can write it as a plus b in this way, or we can write it as a plus b stacked. Subtraction, the same thing, we can write it as a minus b this way, or we can write it stacked, a minus b. Now multiplication can be written as a with the little x here, b. It can be written as a times b stacked, like this. It can be written as a times b with the little dot, or it can be written as a times b with the parentheses. So anytime you see them pushed together, that means multiplication, so this is a times b. Now division. Division can be written as a divided by b with this little division symbol. It can be written in long division form as a divided by b. Or it can be written as a fraction, a divided by b like this. It can also be written as a slash b. So these are all ways we can write integer operations. Now, how do we recognize word problems? Addition can state a plus b, just like that. It can also be a added to b. It could be a more than b. So I could say I have 3 more apples than oranges. How much fruit do I have? And we could say a combined with b. And lastly, the sum of a and b. So the big one that you need to remember is the sum. Sum of a and b means addition. Now subtraction can be a minus b. It can be a subtracted by b. It could be b less than a. It could be b taken away from a. Or the big one that I need you to remember is the difference of a and b. Now multiplication can be written as a times b, a multiplied by b, a groups of b, so we could have 12 groups of 4, for instance. And the one I really need you to remember is the product of a and b. Now division can be written as a divided by b, a over b, and the one I really need you to remember is the quotient of a and b. Now there's a video here that shows you how you can check integer operations using Symbaloo. So you can use that to check your work. Let's take a look now at how we can check our answers on Symbaloo for integer operations. So we go to Symbaloo.com and we're going to go ahead and put in our integer operations. So let's say we had a question that said -5 minus -4. And we can go ahead and click go, and it'll show us not only the answer, but step by step how to do this. So we should see that we had -5 minus -4, and when we have a minus a negative, it becomes plus positive, which they did here, so it's -5 plus 4, which is -1, and that's our answer. So this is one way you can use a resource to check your work once you've already solved. So once you've solved an integer operation, we can always go back and check it. We can do it with any operation. So let's make it -5 times -4. We click go. It shows us here. We multiply them together and we get positive 20. So we can check our work anytime we need to using Symbalab for integer operations. Now let's talk about the parts of a fraction. We have a fraction here with 1/3. The top number we call the numerator. The bottom number we call the denominator. Now let's look at our rules for adding fractions. So first thing we have to decide is, do they have the same denominator or not? So does this number match this number? Well, in this case we can see that they do. They're both 2. So if they have the same denominator, our rules are, we're going to use the addition rules on the numerator, so we're going to add the numerators and keep the denominators the same. So this will be 1 plus 3, and we'll leave the denominator as 2. If we have different denominators, we're going to change the fractions to get a common denominator, and then we're going to use our addition rules on the numerators and keep the new denominator the same. So what does this look like? Well, we have an example here of 1/3 plus 1/3. Well, we can see they have the same denominator. So therefore, we're going to add the numerators, so 1 plus 1, and we're going to leave the denominator as it is, so that's 3. So it's 1 plus 1 over 3, and 1 plus 1 is 2, so that's 2 over 3. Here's another example. We have 3 over 4 plus 1 over 4. Notice, same denominator, so we're just going to add the numerators, 3 plus 1, and that's over 4. 3 plus 1 is 4, so that's 4 over 4. And in reality, this is 4 divided by 4. So we always simplify our fraction, and it's 1. Now we have 1 over 2 plus 4 over 2. So we're going to add the numerators, 1 plus 4, and keep the denominator the same. So 1 plus 4 over 2, which is 5 over 2. Always leave it as an improper fraction. Do not convert it to a mixed number. So even though 5 is bigger than 2, that's okay. We're just going to leave it as 5 over 2. Do not change it to be 2.5. Subtraction rules with fractions. So subtraction rules are just the same as addition rules. So we're going to decide if they have the same denominator or not. If they do, we'll use our subtraction rules on the numerators and keep the denominator the same. If they have different denominators, we're going to change them to get common denominators and then use our subtraction rules on the numerators and keep the denominator the same. Let's look at some examples here. So we have 2 over 3 minus 1 over 3. Notice, same denominator. So we're just going to subtract the numerators. So 2 minus 1 over 3. Well, 2 minus 1 is 1, so that's 1 over 3. Now this one here, we have 3 over 4 minus 1 over 4. Notice both have the denominator of 4. So we're going to go ahead and subtract the numerators. So 3 minus 1 over 4. And 3 minus 1 is 2. So that's 2 over 4. Notice we're going to simplify our fraction. So we should see that there's a 2 in common in both the numerator and denominator. So we're going to divide the top and bottom by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2, so it's 1 over 2. Let's look at another one. We have 1 half minus 4 halves. So again, same denominator. So we're just going to subtract the numerator. So 1 minus 4. So 1 minus 4 is negative 3 over 2. So it's just negative 3 halves. And again, always leave it as improper fraction. Do not change it to be negative 1.5. So just leave it just like that. Now how do we find a common denominator? So what happens if the denominators don't match? Like this, we have 1 half plus 3/4. Well, we need to find a common denominator by finding the least common multiple of the two values. So we need to find the least common multiple of 2 and 4 in this case. Now, the question we should always ask ourselves first is, if we look at the smaller number, is there anything I can multiply it by to get the bigger number? Which in this case, I can multiply it by 2 and I'll get 4. So 4 would be my least common multiple. If not, then I'll have to multiply both sides by the other denominator. So our expression then should look something like this. Something over 4 plus something over 4. So we know it should look like that. So now we need to figure out what we need to multiply 1 half by to get a denominator of 4. Well, we know that we need to multiply 2 by 2 to get 4. So we're going to have to do it to both the top and bottom. So we're going to multiply both top and bottom by 2. So we get 2 over 2 times 1 over 2 is equal to 2 over 4. Because 2 times 1 is 2. 2 times 2 is 4. So this is 2 over 4 plus 3 over 4 now. Let's take a look at a couple examples. We have 1 half plus 1/4. So again, we look, is there anything I can multiply 2 by to get 4? Well, we can multiply it by 2. So we're going to multiply 1 half times 2 over 2, which is 2 over 4. Then we'll add that to 1/4. 2 plus 1 is 3, and we leave the denominator as is, which is 4. So it's 3 over 4. Now 2 over 3 minus 1 over 9. So we look at our smaller number, which is 3, and we know that we can multiply it by 3 to get 9. So we're going to multiply this one, both top and bottom, by 3. So 2 over 3 times 3 over 3 is 6 over 9. Now we're going to subtract 6 over 9 minus 1 over 9. And we get 6 minus 1 is 5. And we leave the denominator, so it's 5 over 9. Now, if we get a situation like this, so 1/2 plus 1/3, I can't multiply 2 by anything to get 3. So I'm going to have to multiply both. So I'm going to multiply this one, top and bottom, by 3. And I'm going to multiply this one, top and bottom, by 2. And that should give me a denominator of 6. So let's go ahead and do that. So I multiply 1/2 times 3 over 3, which is 3 over 6. And I multiply 1 over 3 times 2 over 2, which is 2 over 6. Now I can go ahead and add those together. So I have 3 over 6 plus 2 over 6. So I'm going to add the numerators. 3 plus 2 is 5. And the denominator stays the same, so it stays as 6. Now, 1 over 3 minus 1 over 4. Again, I can't multiply 3 times anything to get 4. So I'm going to have to multiply this one top and bottom by 4. And this one top and bottom by 3. So 1/3 times 4 over 4 is 4 over 12. And 1 over 4 times 3 over 3 is 3 over 12. Notice now my denominators match. So now I can just subtract the numerators. So 4 minus 3 is 1, and I leave the denominator as is. First of all, let's talk about our multiplying fractions rules. The rules are that the denominators do not matter, which means they do not need to match. So we can have uncommon denominators. We're going to multiply the numerators and keep them as the numerators. So we would multiply 5 times 3. Then we're going to multiply the denominators and keep them as the denominators. So 2 times 2. So let's look at some examples. We have 1/2 times 1/2. Well, we're going to multiply the numerators, and we get 1 times 1. And then we're going to multiply the denominators. So that's 2 times 2. So 1 times 1 is 1, and 2 times 2 is 4. So we get 1 over 4 as our answer. Now we have 3 over 4 times 1/2. Denominators don't match. That's okay. We don't need them to match. So we're just going to multiply the numerator, 3 times 1, and the denominator, 4 times 2. So we get 3 times 1 is 3, 4 times 2 is 8, so we get 3 over 8. Now we have 1/3 times 1/9. So again, we're going to multiply the numerators, 1 times 1, and the denominators, 3 times 9. So 1 times 1 is 1, and 3 times 9 is 27. So we should end up with 1 over 27. Now we have 1 over 4 times 2 over 3. Well, we're going to multiply the numerators, 1 times 2, and the denominators, 4 times 3. So 1 times 2 is 2, and 4 times 3 is 12. Remember, we always need to simplify. So is there anything in common between 2 and 12? Well, we notice that 2 is, so we're going to divide both the top and bottom by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. So we get 1 over 6. Now, dividing fraction rules. Again, the denominators do not matter, so they do not need to match. Now, the rule is we cannot divide two fractions. We must convert to multiplication by changing the second fraction to its reciprocal, which the reciprocal just means we're going to take 3 over 2 in this case and flip it over so it becomes 2 over 3. So in this case, we started with 5 over 2 divided by 3 over 2. We're going to use the concept of freeze, change, flip. So freeze, we're going to freeze 5 halves, which means we leave it exactly as it is. We're going to change, meaning that we're going to change this division sign, and it's going to become multiplication. So now it's 5 halves times. And then flip means we're going to take this number here, 3 halves, and we're going to flip it over so it becomes 2/3. Now we just use our multiplication rules. So let's go ahead and do that. Let's take a look at some examples. We have 1/2 divided by 1/2. So we're going to freeze, change, flip this. So we freeze 1/2, change this to multiplication, and then flip this so this becomes 2 over 1. So now it's 1/2 times 2 over 1. Well, now we just multiply. So we have 1 times 2 and 2 times 1. So 1 times 2 is 2. 2 times 1 is 2. So we get 2 over 2. We look to see, is there anything in common in both the numerator and denominator? Well, we can see that 2 is in common, so we divide both the top and bottom by 2, and we get 1 over 1, which is just 1. Now let's look at this one. We have 3 over 4 divided by 1 over 2. So we're going to freeze, change, flip. So this becomes 3 over 4 times 2 over 1. Now we multiply across. So we get 3 times 2 and 4 times 1. Well, 3 times 2 is 6 and 4 times 1 is 4. Again, we look to see if there's anything in common. There's a 2 in common in both the numerator and denominator. So we'll divide both the top and bottom by 2. So 6 divided by 2 is 3 and 4 divided by 2 is 2. So we get 3 over 2. Now we have 1 over 3 divided by 1 over 9. So we're going to freeze, change, flip. So we freeze 1/3, change this to multiplication, and then flip this to become 9 over 1. So now we have 1/3 times 9 over 1. Now we multiply 1 times 9 and 3 times 1. Well, 1 times 9 is 9, and 3 times 1 is 3. Now we look to see if there's anything in common. Well, we can see that 3 is in common in both the top and bottom. So we divide both top and bottom by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. So we get 3 over 1, which is just 3. One more, we have 1 over 4 divided by 2 over 3. We're going to freeze, change, flip this. So freeze 1/4, change this to multiplication, and then flip this to become 3 over 2. So we get 1 over 4 times 3 over 2. So now we're going to multiply the numerator and multiply the denominator. So we get 1 times 3 and 4 times 2. So 1 times 3 is 3 and 4 times 2 is 8. There's nothing in common, so we leave it just like that. Now what if we have a whole number instead of a fraction? Well, whether it's multiplication or division doesn't matter. What we're going to do is we're going to change this. Instead of it being 1/4 times 2, we're going to rewrite 2 as a fraction, which is just 2 over 1. And then we follow the same steps. So we multiply this 1 times 2 and 4 times 1, which is 2 over 4. And then we would just simplify it. Now there's a video here showing how you can check your work with fractional operations using Symbolab. Let's take a look now at how we can check our work using Symbolab for fractional operations. So we go to symbolab.com. So let's say we have 4 over 5 minus 3 over 2. That was the equation that we were given. And we're going to go ahead and click Go. And notice now it tells me what my answer is in a fraction. It'll also convert it to a decimal. For today's stuff, we just want to leave it as a fraction. So it says that it should be -7 over 10. And it shows me step by step how to do this. So it shows me to get a common denominator. And when I do that, I should get 8 over 10 minus 15 over 10. Once I do that, I subtract the numerators, and I get -7 over 10. So this is one way we can use Symbolab to check our work. And we can do it with any operation. So we could do this with, let's say, division. So let's make this 4 over 5 divided by 3 over 2. If we click Go, it'll give us an answer. It says that it should be 8 over 15. And it shows us step by step how to do this. So this is how you can use Symbolab to check your work when dealing with fractional operations. First of all, why do we need order of operations? So let's compare two ways of completing the problem. So we have 4 plus 8 divided by 2. And 4 plus 8 divided by 2. Now, if we work from left to right, we would add 4 plus 8, which is 12, and then divide that by 2 and we get 6. Well, if we do it with the division first, we get 4 plus 8 divided by 2. 8 divided by 2 is 4. 4 plus 4 is 8. So you can see that we end up with two completely different answers, even though we didn't make any mistakes necessarily. We calculated things correctly, we did all our math correct, but we still ended up with two different answers because we started in two different places. So order of operations is something that's very important. So what are order of operations? The first thing we do is we're always going to use parentheses and grouping symbols. So if there are parentheses, we're going to calculate what's inside the parentheses first. So parentheses look like this. They can be with the parentheses this way, or we could have these brackets as well. So those are parentheses and grouping symbols. Next thing we do is exponents. So exponents look like this, a squared. So it's this number here that's above. So we always do parentheses, then we do exponents. After that, we're going to multiply and divide. Notice they're grouped together. I did not separate multiplication and division. Okay, we always group them together. So it doesn't matter whether it's multiplication or division, we're always going to do them together going from left to right. So multiplication and division like this. After that, we do addition and subtraction. Again, notice they are grouped together. We don't need to do addition and then subtraction. If subtraction comes first, we do that. So we will always do addition and subtraction grouped together, and those symbols look like this. So let's look at an example. We have 2 minus 4 times 3 minus 2 plus 2 squared divided by 2. So first thing we do is parentheses. Well, we can see that we have parentheses here. So we have 3 minus 2, which is 1. Now we look, are there any other parentheses? No, there's no other parentheses here. So now we do exponents. Well, we have exponents here. So 2 squared. 2 squared means 2 times 2, which is 4. So we have 2 minus 4 times 1 plus 4 divided by 2. No other exponents, so now we do multiplication division. Well, we have multiplication here, negative 4 times 1. And we have division here, which is 4 divided by 2. So we're just going to work from left to right. So 4 times 1 is 4. And 4 divided by 2 is 2. Now we can see we don't have any more multiplication or division. So now we're going to do addition and subtraction. So we have 2 minus 4 is negative 2. Plus 2 is 0. And therefore, we've done our order of operations, and we can see that our answer should be 0 using order of operations. Let's look at a couple examples. So we have 4 minus 2 times 3. Well, we have no parentheses. We have no exponents, so we're going to begin with multiplication, which is 2 times 3. So 2 times 3 is 6, so we have 4 minus 6. Now we can just go ahead and add or subtract. So we have 4 minus 6, which is negative 2. So now let's look at this one. We have 4 minus 2 times 3. So we're doing our parentheses first. 4 minus 2 is 2. And then we multiply that by 3. So 2 times 3 is 6. Now we have 8 plus 4 over 2. Well, we have parentheses, so we're going to go ahead and add those together first. So we get 8 plus 4 is 12 divided by 2. 12 divided by 2 is 6. So that would be our answer for that one. Distributive property. So we have 4 times 3 plus 2. So what we're going to do is we're going to multiply the number out front by everything inside. So 4 times 3 plus 2 could be 4 times 3 plus 4 times 2. So that's 4 times 3 is 12. And 4 times 2 is 8. When we add those together, we get 20. Here's how we can check order of operations using Symbol Lab. There's a video here that you can watch. Let's take a look now at how we can check our work using Symbol Lab for order of operations. So let's say that we were given 3 squared minus 4 times 6 minus 3. So something that's written like this. We can go ahead and click Go, and it'll spit out the answer for us. It tells us the answer should be negative 12. And it tells us exactly how that works. So it says for the steps, we should do what's in the parentheses first, beginning with the multiplication. 4 times 6, which is 24, minus 3 is 21. Then we can go ahead and subtract it. So 3 squared is 9, because we calculate the exponents next. And then we subtract from left to right, so we get 9 minus 21, which is negative 12. So this is how we can use Symbol Lab to check our work when dealing with order of operations. What are like terms? Each member of an expression separated by an operation sign is called a term. So in this case, 4 is a term. 2x is a term, negative x is a term, and 3 is a term. So all of these are what we consider terms. Now, like terms have the same variable and same exponent. For instance, 2x and negative x are like terms because they have the same variable, they're both x, and they have the same power, which in this case is an imaginary 1. So those are considered like terms. Likewise, 4 and 3 are considered like terms because they have the same variable, in that the variable is nothing. There is no variable. So that's the same. They have that in common. And they have the same power, the power of 1. So 4 and 3 are like terms, and 2x and negative x are like terms. Now, how do we combine like terms? So first thing we need to know is, what are the parts of these? So the number in front of the variable is called the coefficient. The unknown value, or the letter, is called the variable. And the number that's by itself is considered a constant. So in order to combine variable expressions, we combine the coefficients according to the operation that's given. So for instance, if we had 4x plus 2x minus 4, we would look at these 4x and 2x as like terms, and we would add the coefficients. So we'd add 4 plus 2, which is 6. So this would be 6x minus 4. Commutative property. The commutative property says if everything there listed there is addition or subtraction, we can rearrange it. So for instance, we have 4 plus 2x minus x plus 3. The commutative property says that we can move things around as long as the operations are all addition or subtraction. So we should notice that all the signs here are either addition or subtraction. So we can rearrange them in any order we want. So let's go ahead and put the x's out front and the constants at the back. So because we have addition or subtraction for all of them, we can arrange them in any order we want. So let's go ahead and put the constants at the back and the variables at the front. So we're going to take 2x and write that out front, and we'll write minus x out front, and then we'll move 4 to the back with the plus 3. So now it's a whole lot easier to see what the like terms are because they're all grouped together. So now we can say 2x minus x is x, because that's really 2x minus 1x. So we can subtract the coefficients. So 2 minus 1 is 1. And then we can add the constants. 4 plus 3 is 7. So we get x plus 7. Now there's a video here that I'd like you to watch that shows you how you can check your work when dealing with like terms using Symbolab. Let's take a look now at how we can check our work using Symbolab when dealing with combining like terms. So let's say we were given something like this: 2x squared minus 4x plus 6x minus 2. So we're asked to combine like terms. We're going to go ahead and click Go. And notice now if we scroll down, they combine the like terms here. We have 2x squared minus 4x plus 6x minus 2. It says add the similar elements. So it tells me which ones I'm going to combine. Negative 4x and 6x, and I get 2x. So it should end up being 2x squared plus 2x minus 2. So that's how we can use Symbolab to check our work when dealing with combining like terms. Now, what are variable equations? A variable is a symbol used to represent an unknown quantity. In this case, it is the x. It's the unknown. It's some letter, usually. A constant is a known fixed quantity that is independent of the variable. So it's a value that we do know. For instance, 2 would be a constant. And a coefficient is a scale factor. It's what we're multiplying the variable by. The equation represents the entire thing. So it represents the entire relationship between the two quantities. So in this case, the variable is x. The constant, in this case, is blue. That's the 2 and the 4. The coefficient is 3. And the equation is the entire thing. So we're saying that everything on this side is equal to everything on this side. Now, how do we solve variable equations? The goal is to get the letter or the variable by itself. So we need to get everything away from the variable. And the way we do that is we're going to move everything, the constants and the coefficients, to the other side of the equal sign. So all the numbers go to one side and the variable stays by itself. Notice that when we do this, whatever we do to one side, we have to do to the other side. So if we subtract 2 from the left, we have to subtract 2 from the right as well. So here's an example. 4x minus 3 is equal to 9. Now, our rule is we need to get x by itself, and we need to get the 4 and the 3 away from the x. Now, where do we begin? We could get rid of the 4 or the 3. Now, the easiest solution is always to get rid of whatever's furthest away from the x first. So, in this case, we can see that we have a 4 and a 3. Those are the two that we need to get rid of, and we're going to pick from those two and say which one's furthest away. Well, the 4 is attached to the x, so the 4 is really close. The 3 over here is kind of floating, so we're going to get rid of that one first. So we'll go ahead and add 3 to both sides. And we're left with 4x by itself. Negative 3 plus 3 is 0, so that's really 4x plus 0, which is just 4x. And we have 9 plus 3 is 12. So we're left with 4x is equal to 12. Now we get rid of the next variable. So we just keep doing this, whatever's the next furthest away. We just keep doing that process until we get x by itself. Well, the only number that's left is the 4, so we're going to get rid of that one next. So we have 4 times x is equal to 12. So we're going to undo multiplication by dividing. So we divide both sides by 4. And we get x by itself is equal to 12 divided by 4 is 3. So in this case, we get x equals 3. Let's look at another example. We have x over 4 minus 3 is equal to 9. So we're going to do the same thing. First thing is we need to get x by itself. So we need to get rid of the 3 and the 4. And we're going to start by getting rid of whatever's furthest away. So in this case, the 4 is kind of attached to the x. The 3 is out here floating. So we're going to get rid of that first. So we're going to add 3 to both sides to get rid of this minus 3. And we get x over 4 is equal to 9 plus 3 is 12. Now we get rid of whatever's next furthest away, which in this case, the only thing that's left is the 4. And the 4 is dividing from x, so we undo that by multiplying. So we'll multiply both sides by 4, and we get divided by 4 and times 4 cancels out, so we got x by itself is equal to 12 times 4, which is 48. Now there's a video here for you to watch that shows you how you can check your work on multi-step equations using Symbolab. Now, our rule is we need to get x by itself, and we need to get the 4 and the 3 away from the x. Now, where do we begin? We could get rid of the 4 or the 3. Now, the easiest solution is always to get rid of whatever's furthest away from the x first. So, in this case, we can see that we have a 4 and a 3. Those are the two that we need to get rid of. And we're going to pick from those two and say which one's furthest away. Well, the 4 is attached to the x. So the 4 is really close. The 3 over here is kind of floating. So we're going to get rid of that one first. So we'll go ahead and add 3 to both sides. And we're left with 4x by itself. Negative 3 plus 3 is 0. So that's really 4x plus 0, which is just 4x. And we have 9 plus 3 is 12. So we're left with 4x is equal to 12. Now we get rid of the next variable. So we just keep doing this, whatever's the next furthest away. We just keep doing that process until we get x by itself. Well, the only number that's left is the 4, so we're going to get rid of that one next. So we have 4 times x is equal to 12. So we're going to undo multiplication by dividing. So we divide both sides by 4. And we get x by itself is equal to 12 divided by 4 is 3. So in this case, we get x equals 3. Let's talk about how we can solve this multi-step equation. So we have x minus 4 over 2 plus 4 is equal to 6. So remember our rule is get rid of everything that's not the variable, starting with whatever's furthest away on the same side. So if we look, the 4 is grouped with it, the 2 is underneath it, and this 4 is just kind of floating around. So the 4 should be what we get rid of first. So it's a positive 4. So we're going to undo that by subtracting 4 from both sides. That'll get rid of this 4. So we get 4 minus 4 is 0. And 6 minus 4 is 2. So we're left with x minus 4 over 2 is equal to 2. Now we need to determine what's furthest away from the x. Well, we can see that we have this negative 4 and this positive 2. Those are the two that we need to get rid of. The negative 4 is grouped with the x up here. The 2 is floating kind of at the bottom. So we're going to get rid of the 2 next. So the 2 is being divided by this, right? So we're going to undo it by multiplying. So we'll multiply both sides by 2. And 2 times 2 is 1. Anything divided by 1 is just itself. So we're left with x minus 4 over here is equal to 2 times 2, which is 4. Now we have x minus 4 is equal to 4. We just have this 4 to get rid of. So we're going to get rid of that one next. It's subtracting 4, so we're going to undo that by adding 4 to both sides. And we get x is equal to 4 plus 4, which is 8. Now what if I have variables on both sides? Well, if we have variables on both sides, we're going to move all the variables to one side and all the constants to the other side. So we're going to group these together. We can see that we have a 2x and a negative 4x. Those are my variables. And I have a negative 6 and a negative 12. Those are my constants. So I'm going to move all the numbers to one side and all the variables to the other side. So I could move this 2x to the other side, or I could move the negative 4x to this side. I'm going to move the negative 4x because that'll keep it positive. So I'm going to add 4x to both sides, and I get 2x plus 4x is 6x. These cancel out, so I'm left with 6x minus 6 is equal to negative 12. Now I can just solve for x. So I'm going to get rid of this negative 6, so I'm going to add 6 to both sides. And I get 6x is equal to negative 12 plus 6 is negative 6. Now I need to get rid of this 6 that's in front of the x. Notice that the 6 is being multiplied by x. So I undo that by dividing both sides by 6. And I get x by itself is equal to negative 6 divided by 6, which is negative 1. So let's look at a couple of examples here. We have x plus 2 over 3 is plus 4 is equal to negative 9. So I'm going to get rid of whatever's furthest away first. Well, this 2 is grouped with it. The 3 is kind of grouped with it as well. The 4 is floating, so I'm going to get rid of that first. So I'm going to subtract 4 from both sides to undo the addition of 4. So what I'm left with is x plus 2 over 3 is equal to negative 9 minus 4. Well, negative 9 minus 4 is negative 13. Now I need to get rid of whatever the next furthest away is. Well, the 2 is up here with the x, and the 3 is kind of floating below, so I'm going to get rid of the 3 next. The 3 is dividing, so I'm going to undo that by multiplying both sides by 3. So these will cancel out. I'm left with x plus 2 is equal to 3 times negative 13. Well, 3 times negative 13 is negative 39. So I got x plus 2 is equal to negative 39. I'm going to undo this addition of 2 by subtracting 2 from both sides. So I'm left with x is equal to negative 39 minus 2, which is negative 41. Now let's look at this example here. We have 6 times x minus 4 is equal to negative 36. So I could distribute this, but I don't need to. I'm going to get rid of whatever's furthest away first. So the negative 4 is inside the parentheses with the x, so I'm going to get rid of this 6. Well, the 6 is multiplying by these things here, so I'm going to undo it by dividing by 6. And I'm left with x minus 4 is equal to negative 36 divided by 6, which is negative 6. Now I have a minus 4 here, so I'm going to undo that by adding 4 to both sides. And I get x is equal to negative 6 plus 4 is negative 2. Let's look at a couple of examples of variables on both sides. So I have 6x minus 4 is equal to negative 2x plus 16. So again, I got to get all my variables to one side and all my constants to the other side. So I have 6x and negative 2x. Well, I want to keep it positive if I can, so I'm going to go ahead and add 2x to both sides to get rid of this. So I add 2x to both sides, and I get 6x plus 2x is 8x. So 8x minus 4 is equal to 16 is all that's left over here. Now I'm going to solve. I get rid of whatever's furthest away from the x first, which in this case is the 4. So I'm going to add 4 to both sides. I get 8x is equal to 16 plus 4, which is 20. Now I divide both sides by 8, and I get x equals 20 over 8. Notice 20 cannot be divided by 8, so I just leave it as 20 over 8. And I could simplify that, and when I do that, I divide both the top and bottom by 4. So 20 divided by 4 is 5, and 8 divided by 4 is 2, so it's 5 over 2. Now we have 1/3 x minus 2 is equal to 1/6 x minus 4. We do the same thing. So I'm going to go ahead and subtract 1/6 x from both sides. So now I have 1/3 x minus 1/6 x minus 2 is equal to negative 4. Now I need to get a common denominator. I can see that my common denominator should be 6, right? Because 3 times 2 is 6. So this is really 2/6 minus 1/6 x minus 2 is equal to negative 4. Well, 2/6 minus 1/6 is 1/6. So this is 1/6 x minus 2 is equal to negative 4. So I'm going to go ahead and add 2 to both sides. And I get 1/6 x is equal to negative 4 plus 2 is negative 2. Now 1/6 is multiplying by x. So I'm going to undo that by multiplying by the reciprocal, which is 6 over 1, or 6. So I'm left with x by itself is equal to 6 times negative 2, which is negative 12. Now there's a video here for you to watch that shows you how you can check your work on multi-step equations using Symbolab. Let's take a look now at how we can check our work using Symbolab for multi-step equations. So we go to symbolab.com and we go into this bar here, and we can go ahead and put our equation. So let's say we had an equation x over 4 minus 3 is equal to 12. So that was our equation. We wrote it in here, and we're going to go ahead and click go. And it'll give us our answer here, but it'll also show us step by step how to do this. So it tells us first we should add 3 to both sides. And we end up with x over 4 is equal to 15. It says now multiply both sides by 4. So we multiply both sides by 4, and we get x equals 60. So it shows us step by step, and we could make this as complicated as we want to. This could be x minus 5 up here. Now we click go. It'll still tell us how to do it. So it'll say add 3 to both sides, multiply both sides by 4, and then add 5 to both sides, and we get 65. So we can use Symbolab to help us check our work when dealing with multi-step equations. Let's take a look now at the Foundational Skills Review assignment. So if you notice, our assignment begins with our learning goals and success criteria. If we scroll down, it asks us a series of questions. The first ones are on integers. So this one says negative 16 plus 14. So we start at negative 16 and we're going to go to the right 14. So we're adding this up. So we end up with negative 2 as our answer. And let's try another one. Let's look at this one. So we're multiplying 1/5 times negative 2/3. Well, it's a positive times a negative, so we know it's going to be negative. And then we're going to multiply the numerator and multiply the denominator. So 1 times 2 is 2, and 5 times 3 is 15. So it should be negative 2 over 15, which is this one here. So you'll go ahead and answer all these questions. When you're done, you'll get to the bottom of the page and click Next. This will take you to your Before You Go. Go ahead and answer the questions on the Before You Go, and then submit your work on Google Classroom.